So as like one electron system, now we'll see titration curve for metal EDTA titration. Titration curve for metal EDTA titration. Okay, so here in this case EDTA titrations, the when PM, this is PM stands for, EM stands for metal ion. Okay, as like a pH, see here it is a PM. Okay, what is PM? PM is a negative log to the base 10 into concentration of m raised to n plus. Okay, so this is the concentration of corresponding metal ion. Okay, जो की आपण स्टडीला घेणार आहोत EDTA titration मध्ये, that is the metal ion. Okay, as the ordinate is plotted against the volume of EDTA titrant. What it means? On y-axis you are going to take the PM values. Okay, on x-axis you are going to consider the values of volume of titrant to be added. Okay, volume of titrant to be added, or volume of titrant added during the titration. Okay, so consider this is what example. Take a 10 centimeter cube of 0.01 molar Ca2 plus solution. Okay, and having buffer pH 10. It is titrated with the EDTA having concentration 0.01. But remember, before doing the titration, we need to carry out the standardization of EDTA. Okay, even if our laboratory analyst or laboratory assistant prepare the EDTA solution as a concentration of 0.01 molar, most of the time what happens, due to different factor, the concentration may vary. Okay, and for that sake we need to find out exact concentration of EDTA before starting the actual analysis of calcium or respective metal ion present in that titration. Okay, so here we will find out the PCA values. We will find out the PCA. Okay, जे वरती तुम्ही PM म्हणाला होतात, आता आपण खाली कॅल्शियम आयनचं सोल्युशन घेतलेलं आहे म्हणून we will call as a PCA values. Okay, so PCA values at the start of titration, then PCA value after the addition of 1 centimeter cube of titrant, then after addition of 5 ml of titrant, then at the equivalence point after the addition of 11 centimeter cube of titrant. Okay, so all these are the volume. Okay, these are the volume of EDTA which you are adding from the burette to the conical flask, in which your analyte is present. What is analyte? Here analyte is a calcium 2 plus ion, right? So we'll see all the values at the respective additions, and that values of PCA we are going to consider to plot the graph. See, now we have the two values KMY is equal KMY for the Ca Y2 minus is a 5 into 10 raised to 10, and alpha 4 value is a 0.35. Okay, as we have seen, alpha 4 value at the pH 10. Alpha 4 value at the pH 10. See, where it is a pH 10. Yeah, this is what the pH 10. Alpha 4 value is 0.35. 0.35. See here, 0.35. Okay, therefore we need that values during the practical. Okay, and we take it from the literature. Now, how to find out K-my? You have formula K-my is equal to KMY into alpha 4. Here it is, K-my is equal to KMY into alpha 4, right? So put the values. So what is K-my? It's a 1.8 into 10 raised to 10. 1.8 into 10 raised to 10. Now at the start of titration, the concentration of Ca2 plus ion is how much? 0.01 molar. Therefore, PCA is equal to negative log of Ca2 plus ion. So value of PCA is 2 at the start of titration. Okay. Now, when 1 ml of titrant, that is EDTA added, when 1 mol of titrant, that is EDTA, 1 ml of titrant, that is EDTA is added. मग आता कोनिकल फ्लास्क मध्ये आपण कॅल्शियम आयन सोल्युशन घेतलंय, ती किती ml रिएक्ट होईल जर 1 ml EDTA टाकला, त्याचंही कॉन्सन्ट्रेशन 0.01 आहे आणि कॅल्शियमचंही कॉन्सन्ट्रेशन 0.01 आहे, आणि आपल्याला माहिती की एक EDTA मॉलिक्यूल हा एका कॅल्शियम आयन बरोबर रिएक्ट होतो. म्हणजे तुम्ही जेवढं वरतून ml जेवढं टाकाल तेवढं ml खाली कोनिकल मध्ये रिॲक्ट झालेलं असेल. मग आता 1 ml टाकलं म्हणजे खालचा 1 ml कॅल्शियम रिॲक्ट झाला. मग किती ml कॅल्शियम राहिलाय कोनिकल मध्ये? कोनिकल मध्ये किती ml कॅल्शियम राहिलाय? 9 ml राहिलेला आहे, ऑफ विच कॉन्सन्ट्रेशन इज 0.01 and total volume is 11 now because you have added 1 ml of EDTA from the burette. So here this is what the concentration of calcium at that stage. So you can calculate PCA is equal to negative log to the base 10 into 0.0082. So the respective PCA value you will get here. Okay. At the equivalence point किती ml ऍड करतात तुम्ही? 10 ml ऍड करतात. टायट्रंट कोणता आहे? ब्युरेट मध्ये भरलेला EDTA भरलेला आहे. कोनिकल मध्ये काय घेतलाय? कॅल्शियम आयन सोल्युशन घेतलेलं आहे कोनिकल मध्ये. अगोदर 10 ml याच्यामध्ये आहेच 10 ml आणि वरतून पुन्हा इक्विलिब्रियम पॉइंट म्हणजे ऑलमोस्ट 10 ml ऍड केलेला आहे. 10 plus 10 how much it is now? It's a 20 ml now. It's a 20 ml. See now. आता इथं बघा काय करतात तुम्ही. What happens here? See, since total volume is 20 ml, the concentration of complex CaY2 minus, you are not considering the calcium concentration here. Here you are considering CaY2 minus will be 0.005. Will be 0. How that is? See, किती ml टाकलेला आहे वरतून? वरतून किती ml टाकलाय? 10 ml टाकलेला आहे. बरोबर? तर आता कॉम्प्लेक्सचं कॉन्सन्ट्रेशन घेतोय आपण. This is not the concentration of calcium. इथपर्यंत कॅल्शियम कन्सिडर केला. इथे कॉम्प्लेक्सचं कॉन्सन्ट्रेशन सांगतोय. ते 10 ml वरतून EDTA टाकलेला आहे. ओके. द कॉन्सन्ट्रेशन वॉज 0.01 मोलर. टोटल व्हॉल्यूम झालाय 20. टोटल व्हॉल्यूम झालाय 20. So the concentration is 0.005. Okay. Now, but at the end point, concentration of Ca2 plus ion is equal to Cy. Concentration of Ca2 plus minus 2 plus is equal to Cy. Is a Cy. Okay. Therefore, K dash My is equal to what? CaY2 minus concentration of our complex, this complex, upon concentration of Ca2 plus into Cy. Right? But we know that Ca2 plus is equal to Cy. Therefore, can I write here? You know the value of K dash My. जी तुम्ही अगोदर काढलेली आहे. कुठे काढलेली आहे? Here it is K dash My. Right? This value. Okay. Now from this equation, see what is value of K dash My? This is value of K dash My. So what is the concentration of complex? It's 0.005 molar. As Ca2 plus is equal to Cy, can I write here as a Ca2 plus bracket square? Here it is a square. Okay, now shift this to this side and this value to this side. What you will get? The equation like this. पण याचा स्क्वेअर आहे. मग हा स्क्वेअर इकडे काय झालं? कन्वर्ट केलेला आहे. याचा स्क्वेअर रूट घेतला तेव्हा तो कॅल्शियम झालेला आहे. इथे येते ना लक्षात? ही जर व्हॅल्यू इकडे जर घेतली है ना, Ca2 plus square is equal to 0.005, right? Upon what? Upon what? 1.8 into 10 raised to 10 raised to 10. 10 raised to 10. हा काय आहे? स्क्वेअर आहे. आम्हाला जर Ca2 प्लस इथे फक्त Ca2 प्लस ठेवायचा, हा स्क्वेअर काढायचा असेल तर मी काय करतो? आय नीड टू टेक द स्क्वेअर रूट ऑफ दिस व्हॅल्यू. देन ओनली दिस विल बिकम Ca2 plus concentration. Ca2 plus. Okay. So I have taken square root of this value. Square root of this value. I got Ca2 plus as this. So I calculated PCA is equal to negative log of this value. 5.2 into 10 raised to minus 7. That is equal to 6.28. Okay. Now, after addition of 11 ml of titrant, after addition of 11 ml of titrant, what happens? See, now you are adding excess of EDTA. How much excess is added? 1 ml. Okay. What is the concentration of EDTA? 0.01. Total volume will become 21. कारण ऑलरेडी 10 आहे त्याच्यात कोनिकल मध्ये आणि वरतून 11 टाकला व्हॉल्यूम, टोटल झाला 21. So what is its concentration? See, here it is. EDTA concentration is this much. Okay, therefore Cy is equal to this one. Okay, now what is CaY2 minus? That will remain 10. तो 10च राहणार आहे. कॉम्प्लेक्स आता काय वाढणार नाही, कारण टोटल रिएक्शन झाली. कोणाचे जेवढे कॅल्शियम होते सर्वच्या सर्व कोणाबरोबर रिएक्ट झालेले आहे? Ca2 प्लस Y4 मायनस रिएक्ट झालेले आहे, बरोबर ना? Y4 मायनस बरोबर रिएक्ट झालेले आहे, बरोबर. आणि इथे काय झालेलं आहे? हे 2 प्लस आणि 4 मायनस विल बिकम 2 मायनस, म्हणून इथे या कॉम्प्लेक्स वरती 2 मायनस चार्ज आहे, बरोबर. नाव 10 into 0.1 upon 21. So concentration of CaY2 minus is 4.76 into 10 raised to minus 3. 10 raised to minus 3. इथे EDTA चं concentration काढलेलं आहे आणि इथे complex चं concentration काढलेलं आहे. Okay, so substituting above values of what? CaY2 minus and C. Here it is. CaY2 minus, you know, now you know the Cy, you know the Cy, right? Now you have to find out the value of Ca. You know the K dash My. What is Ca? Take Ca2 plus to this side, K dash My to this side. What will happen? See now. This is 1.8 into 10 raised to 10, right? Here 4.76 into 10 raised to minus 3 upon Ca2 plus ion concentration into 4.76 into 10 raised to minus 4. So from here you can shift this to this side, Ca2 plus to this side. Okay, you can find out here what is the concentration of Ca2 plus ion. So 5.55 into 10 raised to minus 9, from which we can calculate the value of Pca. Negative log of 5.5 into 10 raised to minus 9 is 8.26. 8.26. Now all these values of Pca, okay, all these value of Pca we are considering for the plotting of a graph. So when 0 ml means at the initial stage Pca value was 2. When 1 ml of EDTA added, the corresponding value of Pca was 2.09. When 5 ml of EDTA added, then corresponding value of Pca was 2.48. When at the equivalence point, the Pca value of was the 6.28. When 11 ml of EDTA added, Pca was 8.26. Similarly, you can find out when 12 ml of EDTA added, Pca value will be the 9.56. Now you are taking Pca value on the y-axis and volume of EDTA added from the burette to the x-axis, and you have to just plot the values over here. इथे तुम्हाला dot ठेवायचे आहे, and after that you have to connect all the dots. Okay, so you will get the graph like this. Okay, and this is what the region or where you will get your end point. Hence, this is called as the equivalence point over here. Okay, so in this way we can plot the graph and we can find out the equivalence point of the titration. Now, whatever we have studied for the 1 electron system and for the EDTA titration, we are plotting the graphs, corresponding graphs. Okay, sorry. So as we are plotting the graph, we are plotting theoretically. Nothing is here as a practical. Remember, but in the laboratory when we perform the practical, we find out all this value. We find out all this value practically. Okay, and after that we are plotting the graph. Okay, so there it is not necessary to get exact 10 as an equivalence point. That equivalence point may shift to the lower side or may shift to the higher side, because the EDTA concentration over there may not be the exactly 0.01 molar. Okay, or the whatever concentration of Ca2 plus ion is there given to you, it may not be the same as a 0.01 molar. Hence it means don't consider that 10 will be the always equivalence point over there. Okay, this is just for the understanding of the theory of the titrations. Okay, so this is all about the EDTA titration. Okay, after that we'll see selectivity as a titrant, selectivity of EDTA as a titrant, and what different factors affect on it. So whatever we studied so far, so enough. In the next lecture we'll see remaining part. Thank you.